So now let's move on to elastic collision in 2-dimension. So basically you have an object, say with mass m1, it goes and hits an object which is at rest. So which is at rest at a particular angle, and because of which the object moves in, not in the same straight line, but in another direction, and m1 moves in another direction. So it's not a perfect straight collision. There's some angle, and you get to see this in billiards, especially the game of snooker and all of that, right? So we get to see this. So let's let the velocity be u1 over here, and let this be v1, and let this be v2. This is the object 2 and that's object 1. Okay, so this is m1 and this is m2 basically. Okay, yes, so that you need to keep in mind. And next is we need to resolve it. For that we need to know the theta. This is theta 2, right? Corresponding angle. So we have v2 cos of theta 2, and this is v2 sine of theta 2. And this is theta 1 over here. So this is v1 cos of theta 1, and this is v1 sine of theta 1. And what else do we have? Yeah, and yeah, we'll consider up and right as positive. Okay, so we are trying to get an equation for the velocity in 2-dimension. Okay, so let's start off with this. Let's consider m1 moving with v1 along the x-axis, and then we have m1 collides with m2 which is at rest. Now after collision, so this is all before collision. Now let's look at after collision. Let the particles move with the velocity of v1 and v2. Let the object or masses move with a velocity of v1 and v2, making an angle of, let me continue over here, making an angle of theta 1 and theta 2 with respect to x-axis. Okay, so as usual, we'll start off with momentum of masses. Okay, so no, this is after collision. Momentum of masses after collision is we have m1s to be m1 v1 and m2s to be m2 v2. Simple. Next we will resolve the momentum. We can write. So first let's resolve along the y-axis. So we have m1s will be, we have this. m1 is v1 sine theta, m1 v1 sine theta, and this will be m2 v2 minus m2 v2 actually. m1 will be m1 v1 sine theta 1, sorry, m2 will be pointing downwards. So this is minus m2 v2 sine theta 2. Then we have along x-axis. So along x-axis will be what? All of this will be cos. Okay. So again, we're just approaching everything systematically, nothing else. So m1s will be m1 v1 cos theta 1. m2s will be m2 v2 cos theta 2. Okay, so all this is well and good. Now we'll make use of using law of conservation of momentum. So we can apply along the axis, along y-axis. So along y-axis, what was the initial momentum? Nothing. Both m1 and m2 had 0 momentum along the y-axis initially. So initially we had m1 dot 0 plus m2 0, no momentum. This should be equal to your m1 v1 sine theta 1 minus m2 v2 sine theta 2. If you think about it, it has to be so, because there was no momentum along the y-axis. So this two has to be equal to each other. Okay. So this is say 1. This is along y-axis. Now it's along x-axis. So along x-axis, what do we have? Well, x-axis initially there was momentum with m1. And now with m2 there was none. Now we have m1 v1 cos theta 1 plus m2 v2 cos theta 2. Very simple, right? So we'll call this as 2. Okay. Finally, since it's elastic collision, as the kinetic energy is conserved, so you can see where we are going with. It's same as what we did with, or not same as, similar to what we did with one dimension head-on collision. So we have half m1 u1 square is equal to half m1 v1 square is half m2 v2 square. Right, these are all energy. So I'll call this as 3. So let's just a second. Okay. So we are at the end of the road. So what is the agenda over here? See, post collision, we have quite a few unknowns, theta 1, theta 2, v1 and v2. So here the unknowns are, so post collision we have theta 1, theta 2 angles, and then velocity 1 and velocity 2. These are all the unknowns. But how many equations do we have? So we have equation 1, equation 2 and equation 3. We have 3 equations but 4 unknowns. So the conclusion. We have 4 unknown but 3 equations. Okay, so we have 4 unknowns but 3 equations, 1, 2, 3. So by experimentally finding one of the unknown, we will be able to calculate the other three. So this is how we can solve this. Okay guys, so our agenda was to figure out the value of theta 1, theta 2, v1, v2. In terms of equation, we cannot, because see, there are many possibilities. Without think about it, let's be practical about it. We know that the angles, it's not a head-on collision. If it's a head-on collision, then indirectly we know theta 1 and theta 2, honestly. Right? So even when we tell head-on collision, one of this, actually two of this is already known, and we're just figuring out v1 and v2. Right? Without knowing one of, like, at what angle we are hitting, we will not be able to figure out v1 and v2 or theta 1 and theta 2. So one of them has to be known. You need to know, okay, this object hit the other object with this mass and this mass at this angle with respect to the x-axis, or the line joining their centers, whatever, or in the direction of its velocity. So directly, indirectly, they can give you information in many ways. Okay. So point is, you need to know one of them. Without that, it's not practical to calculate. Actually, it's not physically possible. So you need to fix one of the things. It hit the second object at this angle, and then you'll be able to proceed with the other calculation. Okay. So that is the basic conclusion. And how do you go on to calculate? Again, this is not formula, honestly. This is a way that you need to calculate. So you know how I do. I draw a diagram and then I start resolving it, and then I'll use conservation of momentum. So v1 sine theta 1 has to be equal to v2 sine theta 2. There's no other option. So that's how I start with, and then the momentum along the x-axis initial has to be equal to final. So there's no point in remembering all of this. And this too there's no point in remembering this. Okay, since you know the fundamentals well, don't memorize any one of it. This is just a way to solve it. This is not a derivation to remember a formula. This is a derivation to understand how we handle the situation. Okay. So yeah, this was just a small exercise.